Right now, as you're watching this video, you're sitting on a tiny speck of dust floating through an ocean so vast that your mind will struggle to comprehend its true scale. That speck is Earth, and it's part of something we call the Milky Way galaxy. But here's what will absolutely shatter everything you thought you knew about our place in the universe. Scientists have just revealed measurements that prove our galaxy isn't the cosmic giant we once believed it to be. It's actually so mind-bogglingly small compared to what lies beyond that. Calling it insignificant would be an understatement. Welcome back to another journey into the deepest mysteries of our cosmos. I'm thrilled you've decided to join me tonight as we explore a discovery so profound that it fundamentally changes how we see ourselves in the grand theatre of existence. Before we dive into this cosmic revelation that will leave you questioning everything, I'd love to know where in the world you're watching from and what time it is in your corner of our pale blue dot. And if you find yourself drawn to these mind-expanding explorations of reality, I'd be incredibly grateful if you hit that like button and consider subscribing to join our growing community of cosmic explorers. Get ready. The journey begins now. Picture yourself standing in the middle of Times Square on New Year's Eve. The lights stretch endlessly in every direction. Buildings tower above you, creating canyons of glass and steel that seem to extend to the horizon. Now imagine that this urban landscape doesn't just cover Manhattan, but spreads across the entire continental United States. Then stretch that cityscape across the Pacific Ocean to Asia. Keep extending it around the entire Earth. Now multiply that distance by 6 billion. You've just visualized the width of our galaxy, but here's where your mind needs to prepare for something that will challenge every intuition you have about cosmic scale. What scientists have recently discovered makes our entire galactic home look like a single grain of sand on a beach that extends beyond the edge of imagination itself. For decades, we've marveled at the Milky Way's impressive statistics. Our galaxy spans roughly 100,000 light-years from edge to edge. That's 600,000 trillion miles of space, filled with an estimated 400 billion stars. Each of those stellar furnaces burns with the power of nuclear fusion, converting millions of tons of matter into pure energy every second. The combined energy output of our galaxy exceeds human civilization's total power consumption by factors so enormous they require scientific notation just to express. These numbers once made us feel like citizens of a cosmic metropolis. We imagined ourselves living in one of the universe's great galactic cities, a sprawling stellar neighborhood that represented something truly significant in the grand scheme of existence. Astronomers classified the Milky Way as a large spiral galaxy, suggesting we inhabited one of the universe's more impressive structures. But recent observations have revealed a truth so humbling that it forces us to completely reconsider our cosmic significance. Advanced space telescopes have peered deeper into the universe than ever before, mapping galactic populations across distances that stretch the very limits of observational capability. What they've found challenges everything we thought we knew about galactic scale and cosmic architecture. The Hubble Space Telescope, working in conjunction with other advanced observatories, has conducted the most comprehensive galactic census in human history. By pointing these instruments at tiny patches of apparently empty sky and collecting light for days at a time, astronomers have created images that reveal the true population of our cosmic neighborhood. Each photograph shows thousands upon thousands of galaxies scattered across space like islands in an infinite ocean. When scientists extrapolated these observations across the entire observable universe, the results were staggering. Conservative estimates now suggest that our cosmic horizon contains approximately 2 trillion galaxies. That's 2 million separate galactic systems, each potentially harboring billions of stars and countless planetary worlds. To put this number in perspective, imagine counting galaxies at a rate of 1 per second without ever stopping to sleep or eat. You would need more than 63,000 years to count them all. Written out completely, this galactic population requires 13 zeros following the number 2. The sheer abundance of cosmic neighbours makes our previous estimates look almost quaint in comparison. But the real revelation comes when we examine where our galaxy fits within this vast cosmic census. The Milky Way, with its 400 billion stars and 100,000 light-year diameter, represents what astronomers now classify as a medium-sized spiral galaxy. Not large, not particularly impressive, simply average among the cosmic multitude. Larger galaxies dwarf our galactic home by extraordinary margins. The Andromeda Galaxy, our nearest major neighbour, contains over 1 trillion stars spread across more than twice our galaxy's diameter. IC 1101, one of the largest known galaxies, spans 6 million light-years and harbours an estimated 100 trillion stars. These galactic giants make our Milky Way look like a cosmic village by comparison. Even more humbling is the realization that many galaxies we once considered distant neighbours actually exist in our immediate cosmic vicinity. The observable universe extends 46.5 billion light-years in every direction, creating a sphere of space so vast that light itself requires billions of years to cross it. Within this enormous volume, our galaxy occupies a region so small it would be invisible on any map attempting to show the universe's large-scale structure. Consider the mathematics of our cosmic insignificance. If we represent each of the 2 trillion galaxies as a single grain of sand, we would need more sand than exists on every beach on Earth to create an accurate model of galactic abundance. Our Milky Way would be just 1 grain among countless others, indistinguishable from its neighbours except for the accident of our presence within it. This revelation extends beyond simple numbers into the realm of cosmic architecture. Galaxies don't scatter randomly through space, but organise themselves into vast networks that resemble biological structures more than anything we might expect from physics alone. Our galaxy belongs to what astronomers call the local group, a gravitational family containing over 50 individual galaxies bound together by invisible forces. But the local group itself represents merely the smallest meaningful unit in a hierarchy of cosmic organisation that grows increasingly complex as we zoom outward. Galaxy clusters contain thousands of individual systems held together by gravitational forces so powerful they bend space and time across millions of light-years. Superclusters represent even larger structures spanning hundreds of millions of light-years and containing hundreds of thousands of galaxies. Our local group belongs to the Laniakea supercluster, a gravitational collection that spans 500 million light-years and contains over 100,000 galaxies. The name Laniakea means immense heaven in Hawaiian, reflecting the structure's overwhelming scale. Yet even this cosmic giant represents just one component in an even larger web of structures that extends to the very limits of observational capability. Recent mapping projects have revealed that superclusters connect to form what scientists call the cosmic web, a 3-dimensional network that resembles soap foam floating in space. Galaxies concentrate along the edges of enormous bubbles, while vast empty regions called cosmic voids occupy the bubble interiors. This web-like architecture extends throughout the entire observable universe with remarkable consistency. The scale of cosmic web components defies human comprehension. Individual filaments stretch across hundreds of millions of light-years, while maintaining widths of only 20 million light-years. These cosmic threads appear impossibly thin when viewed at universal scales, yet they contain enough matter to fuel billions of galaxies. Matter flows along filaments like water through cosmic plumbing, feeding galaxy formation in the densest regions. Galaxy clusters form where multiple filaments intersect, creating gravitational traffic jams that trap matter for billions of years. These cosmic crossroads represent the busiest neighborhoods in the universe, where galaxy interactions trigger star formation and supermassive black hole growth. The most massive clusters mark locations where the cosmic web reaches its highest density. Within this vast architectural framework, our Milky Way occupies a position of stunning mediocrity. We exist in the outer regions of a modest galaxy cluster, located in the suburbs of an average supercluster, threading through one strand of the cosmic web among countless others. No special location, no privileged position, no cosmic significance beyond the accident of our evolutionary emergence within this particular stellar neighborhood. The discovery of our galaxy's true scale has profound implications for how we understand our place in the cosmic hierarchy. Every star visible in Earth's night sky belongs to our galactic neighborhood. The fuzzy band of light that cuts across dark skies reveals our edge-on view of the Milky Way's spiral arms. We live embedded within this structure like a single cell inside a vast organism, able to observe our cosmic home from the inside, but lacking the perspective to appreciate its true context. From our position, roughly 26,000 light-years from the galactic center, we can witness stellar birth and death, observe the complex dance of gravity and nuclear physics that shapes cosmic evolution, and map the distribution of matter and energy throughout our local stellar community. All of this cosmic drama unfolds within what amounts to our immediate galactic neighborhood, while the vast majority of universal structure lies far beyond our direct observational reach. The realization that our galaxy represents such a tiny fraction of cosmic reality forces us to confront uncomfortable questions about human significance and our species' place in the grand scheme of existence. We've spent centuries developing increasingly sophisticated models of our cosmic environment, only to discover that everything we can observe directly amounts to less than 1% of what actually exists. This perspective shift challenges human-centered thinking about cosmic importance in ways that previous scientific revolutions never quite achieved. The ancient belief that Earth occupied the center of creation seems almost reasonable compared to modern revelations about galactic scales. We exist on one planet, orbiting one star, among hundreds of billions, in a galaxy that ranks as perfectly ordinary among trillions of similar structures. Yet perhaps this cosmic humility opens new avenues for wonder and exploration. If our modest galaxy contains 400 billion opportunities for stellar systems, planetary formation, and potentially biological evolution, what possibilities might exist among the 2 trillion galactic neighbors scattered throughout observable space? The same physical laws that govern stellar evolution in our cosmic backyard operate throughout the universe, suggesting that the processes we observe locally represent universal phenomena occurring on scales that dwarf human experience. The story of our galaxy's true scale has only just begun to unfold. Advanced telescopes coming online in the next decade will peer even deeper into cosmic space, potentially revealing galactic populations that dwarf current estimates. Each new observation pushes the boundaries of what we thought possible, consistently revealing a universe far larger, more complex, and more magnificent than our theories predicted. As we peer deeper into this cosmic revelation, something even more extraordinary emerges from the data. The galaxies we can observe tonight represent merely the visible tip of an iceberg, whose true dimensions stretch far beyond our wildest imagination. Scientists working with the most advanced telescopes have made a discovery that transforms our understanding of cosmic scale in ways that should fundamentally alter how every human being thinks about existence itself. Here's what keeps astronomers awake at night, staring at equations that spell out a reality so vast it challenges the very limits of human comprehension. The observable universe, that sphere of space containing our 2 trillion galactic neighbors, might represent less than 1% of what actually exists. Beyond our cosmic horizon lies a realm so immense that it makes our entire observable cosmos look like a microscopic bubble floating in an infinite ocean. This isn't speculation or theoretical wishful thinking. The evidence comes from precise measurements of cosmic geometry conducted by our most sophisticated instruments. When scientists analyzed the cosmic microwave background radiation, that ancient light left over from the universe's birth, they discovered something remarkable. Space itself appears perfectly flat across distances spanning billions of light years. Why does this matter? Imagine standing on Earth's surface. The ground appears flat beneath your feet because our planet is so much larger than your local perspective can detect. Similarly, if the universe were only slightly larger than our observable volume, space would show detectable curvature like the surface of a sphere. But measurements reveal no curvature whatsoever across the largest distances we can measure. This flatness indicates that the true universe extends far beyond our observational limits. Conservative calculations based on cosmic geometry suggest the universe measures at least 7 trillion light-years in diameter. This minimum size exceeds our observable universe by a factor of 75. For every galaxy we can detect, at least 5,000 similar galaxies exist beyond our cosmic horizon. But even this staggering estimate might represent a dramatic undercount. Theoretical models emerging from our understanding of cosmic inflation suggest possibilities that stretch toward mathematical infinity itself. During the universe's first tiny fraction of a second, space expanded by factors that dwarf anything in human experience. The region that became our entire observable cosmos started smaller than a proton before inflation stretched it to cosmic proportions. Yet this inflated volume still constitutes only a microscopic bubble within a vastly larger structure. The same process that created our cosmic neighborhood operated across scales that make our observable universe look like a single atom within a structure the size of Earth. If these models prove correct, our galaxy doesn't just occupy a tiny corner of a large universe. It exists within an infinitesimally small region of something approaching true infinity. The implications cascade through every aspect of cosmic understanding. That fuzzy patch of light you can barely see in the Andromeda constellation, our nearest major galactic neighbor containing over 1 trillion stars, lies a mere 2.5 million light-years away. This distance places Andromeda practically next door in cosmic terms. Yet even this nearby galactic giant, along with every other structure we can observe, exists within what amounts to our immediate cosmic neighborhood. Beyond the edge of observable space stretches a realm containing cosmic structures we will never see, galactic clusters whose light will never reach us, and stellar populations that dwarf our local census by incomprehensible margins. The night sky that seems so rich with stars and distant galaxies actually shows us only the tiniest sampling of what exists throughout the larger cosmic volume. This hidden universe raises profound questions about the nature of reality beyond our observational reach. If space extends as far as theoretical models suggest, then conditions similar to those in our cosmic neighborhood must be repeated countless times throughout the larger structure. Planets identical to Earth might exist in distant cosmic domains. Civilizations equivalent to human society might develop around similar stellar systems scattered throughout the hidden cosmos. The mathematics of infinite space suggests even more extraordinary possibilities. In a truly infinite universe, every possible arrangement of matter must occur somewhere within the vast expanse. This includes not just Earth-like worlds, but perfect duplicates of our entire observable universe repeated throughout infinite space. Identical copies of our galaxy, complete with precise replicas of our solar system, and every human being would exist in numbers approaching infinity itself. Yet this vast hidden realm remains forever inaccessible to human observation or exploration. Even traveling at light speed, explorers could never reach regions beyond our cosmic horizon because expansion carries them away faster than any signal can propagate. the hidden universe represents a domain we can theorize about, but never directly study. Recent observations have provided tantalizing hints about this larger cosmic structure. Advanced analysis of cosmic microwave background patterns has revealed subtle features that might represent shadows cast by structures beyond our observational reach. Some theoretical models predict that interactions between neighboring cosmic regions would leave detectable imprints in the ancient radiation that forms our most distant observable boundary. The search for these cosmic shadows represents one of the most ambitious projects in modern astronomy. Scientists are developing increasingly sophisticated algorithms to analyze temperature variations in the cosmic microwave background, looking for circular patterns or other geometric features that might indicate our observable universe has collided with neighboring cosmic domains during its evolutionary history. Several candidate signals have been identified, though their interpretation remains controversial among cosmologists. If confirmed, these observations would provide the first direct evidence that our cosmic neighborhood exists within a much larger structure. The discovery would transform our understanding of cosmic architecture and our place within it. But perhaps the most unsettling aspect of our galaxy's true scale isn't what we've discovered, but what it reveals about the fundamental nature of existence itself. We live during what might be called a golden age of cosmic visibility. The observable universe currently contains more galaxies than at any previous time in cosmic history, yet fewer than will be visible in the far future. This occurs because cosmic expansion continues accelerating under the influence of dark energy, that mysterious force comprising 68% of universal contents. As space expands at ever-increasing rates, distant galaxies cross permanently beyond our observational horizon. Most cosmic neighbors we can observe tonight will disappear from view within the next 2 trillion years. Future astronomers living in our merged galaxy, after the Milky Way collides with Andromeda, will inhabit a profoundly different cosmic environment. Their night sky will contain almost no external galaxies beyond their local merged system. Deep space will appear empty, except for the cosmic microwave background radiation, which itself will become too faint to detect as expansion stretches its wavelengths beyond instrumental sensitivity. This cosmic isolation creates a disturbing possibility for future science. Astronomers living billions of years from now may have no evidence that other galaxies ever existed. The expansion history of the universe will be erased from observational records. The Big Bang theory might never be discovered because the evidence supporting it will have disappeared beyond detection limits. We exist during a brief cosmic moment when the universe reveals its true scale and complexity to observers capable of understanding these revelations. This temporary window of cosmic visibility makes our current scientific discoveries even more precious and profound. The detection of gravitational waves from colliding black holes, the mapping of cosmic web architecture, the census of galactic populations across vast distances, all of these achievements occur during a unique period when the universe remains sufficiently compact for advanced observations, while containing enough structure to reveal cosmic organization. Every photograph captured by space telescopes, every measurement of cosmic distances, every discovery about galactic evolution contributes to a scientific legacy that future civilizations might never be able to replicate. We are witnessing and documenting cosmic phenomena that will become invisible to observers in the distant future. This realization adds urgency to current astronomical research. The cosmic revelations available to our generation represent opportunities that may never return. Each deeper survey of galactic populations, each more precise measurement of cosmic geometry, each theoretical breakthrough about universal structure helps complete a picture of cosmic reality that future astronomers may find impossible to reconstruct. The story of our galaxy's insignificance within cosmic architecture continues unfolding with each new observation. Advanced telescopes coming online in the next decade will peer even deeper into space, potentially revealing galactic populations and cosmic structures that dwarf current estimates. The James Webb Space Telescope has already begun detecting galaxies that formed earlier in cosmic history than theoretical models predicted, suggesting that galactic evolution proceeded more rapidly than scientists thought possible. These observations hint at cosmic processes operating on scales and timelines that challenge our understanding of how structure forms in the universe. If galaxies could assemble so quickly in the early cosmos, what other surprises might await discovery in regions of space we haven't yet explored? The quest to understand our galaxy's true place in cosmic hierarchy drives some of the most ambitious scientific projects ever undertaken. International collaborations spanning multiple continents coordinate observations across the electromagnetic spectrum, combining data from radio telescopes, optical instruments, X-ray detectors, and gravitational wave observatories to create comprehensive maps of cosmic structure. Each new survey reveals additional layers of complexity in cosmic organization. Structures emerge at scales that theoretical models struggle to explain. Empty regions stretch across distances that shouldn't exist according to current understanding of how matter clumps together under gravitational influence. As we stand on the threshold of discoveries that will reshape our understanding of cosmic scale and galactic significance, one truth emerges with crystal clarity. Our Milky Way, magnificent as it appears from our embedded perspective within its spiral arms, represents nothing more than a single note in a cosmic symphony so vast and complex that human minds can barely grasp its opening movements. The mathematics behind these cosmic revelations become even more staggering when we consider what lies hidden in the spaces between galactic structures. Those vast empty regions that separate our Milky Way from its cosmic neighbours aren't actually empty at all. They contain something so mysterious and powerful that it's reshaping our understanding of reality itself. Scientists have discovered that roughly 68% of everything that exists consists of dark energy, a force so alien to human experience that it defies every intuition we've developed about how the universe should behave. This invisible component of reality is literally tearing space apart, accelerating cosmic expansion at rates that overwhelm gravitational attraction across distances larger than galaxy clusters. Here's what should terrify and inspire you in equal measure. Dark energy doesn't just exist passively in the background of cosmic evolution. It's actively winning a cosmic war against every other force in the universe. While gravity tries to pull matter together into stars, planets, and galaxies, dark energy pushes everything apart with relentless determination. The implications stretch far beyond academic curiosity. Right now, as you process these words, space itself is expanding beneath your feet, carrying distant galaxies away from us at velocities that boggle the mind. Galaxies at the edge of our observable universe are receding at speeds approaching 3 times the velocity of light, not because they're moving through space at impossible speeds, but because space itself is stretching like a cosmic fabric, being pulled in all directions simultaneously. This expansion creates a countdown timer for cosmic observation that should keep every astronomer awake at night. Most galaxies we can see today will eventually disappear beyond our observational horizon, carried away by expanding space until their light can no longer reach us. The universe we observe tonight represents a snapshot of cosmic architecture that will never exist again. Within 50 billion years, the Virgo cluster, that massive collection of galaxies that currently serves as one of our most prominent cosmic landmarks, will fade beyond detection. The most distant galaxies visible through our most powerful telescopes will become invisible as cosmic expansion stretches their light to wavelengths our instruments cannot measure. But the cosmic isolation extends even deeper than observational boundaries. Advanced calculations reveal that our galaxy exists within what scientists call the Hubble volume, a sphere of space measuring approximately 14 billion light-years in radius. This represents the maximum region where signals sent from Earth could theoretically arrive before cosmic expansion carries their destinations permanently beyond reach. Think about what this means for our cosmic significance. The Hubble sphere contains roughly 10,000 times fewer galaxies than the observable universe. Most cosmic neighbors we can see today lie beyond our sphere of influence, meaning we can observe them but never communicate with them through any physical process imaginable. Every day that passes, cosmic regions equivalent to millions of Earth-sized volumes cross permanently beyond our ability to influence through any mechanism. The sphere of space where human actions could potentially matter shrinks continuously as dark energy acceleration increases expansion rates across cosmic distances. This shrinking domain of influence creates profound implications for any attempts at cosmic communication or exploration. Radio signals transmitted from Earth today could theoretically reach galaxies within our current Hubble volume, though journey times would span billions of years for the most distant targets. But each passing moment reduces the number of reachable destinations as expansion carries them beyond the fundamental barrier imposed by light speed limitations. The discovery of cosmic acceleration has revealed something even more disturbing about our galactic neighborhood's ultimate fate. Computer simulations tracking the future evolution of cosmic structure paint a picture of increasing isolation that culminates in what astronomers call the Big Rip scenario. If dark energy continues strengthening, as some theoretical models suggest, cosmic expansion could eventually overcome gravitational forces within individual galaxies. Stars would be torn away from galactic centers, planetary systems would be disrupted. Eventually, even atomic nuclei could be ripped apart by expanding space itself. This cosmic destruction would occur approximately 22 billion years from now, representing the ultimate triumph of dark energy over every other force in nature. The universe would end not in gradual cooling, but in a catastrophic explosion that tears apart every bound structure, from galaxy clusters down to subatomic particles. Yet even less extreme scenarios paint a picture of profound cosmic loneliness. Within 2 trillion years, only galaxies within our local group will remain visible to observers in our cosmic neighborhood. The night sky will appear almost completely empty, except for our merged galactic system and the fading cosmic microwave background radiation. Future astronomers living in this isolated cosmic environment will inhabit a universe that appears fundamentally different from the one we observe today. They may have no evidence that other galaxies ever existed beyond their local merged system. The rich tapestry of cosmic structure that drives current astronomical research will have vanished beyond detection limits. This temporal perspective adds another layer to our galaxy's insignificance within cosmic architecture. Not only do we exist in a tiny corner of an enormous universe, but we live during a brief historical moment when cosmic structure remains visible across vast distances. Our current ability to map galactic populations and cosmic organization represents a temporary window that will close as expansion continues. The realization that we exist during a golden age of cosmic visibility makes current astronomical discoveries even more precious. Every deep field image revealing thousands of distant galaxies, every measurement of cosmic distances, every theoretical breakthrough about universal structure contributes to a scientific legacy that future civilizations may never be able to replicate. But perhaps the most mind-bending aspect of our galaxy's cosmic insignificance emerges when we consider the possibility of infinite cosmic structure extending beyond our observational reach. Theoretical models suggest that our observable universe, containing 2 trillion galaxies across 93 billion light-years of space, might represent an infinitesimally small component of total cosmic reality. If eternal inflation theories prove correct, new space constantly forms through quantum processes occurring beyond our cosmic horizon. This creates infinite numbers of observable, universe-sized regions within an ever-expanding cosmic structure. Each region would contain its own collection of galaxies, stars, and planets, isolated from neighboring domains by expansion rates that exceed light speed. The mathematics of infinite space suggest possibilities that challenge every assumption about uniqueness and significance. In an infinite multiverse, every possible arrangement of matter must occur somewhere within the vast expanse. This includes not just Earth-like worlds, but perfect duplicates of our entire observable universe, repeated throughout infinite space. Identical copies of our Milky Way, complete with precise replicas of our solar system, and every human being who has ever existed, would exist in numbers approaching mathematical infinity. These parallel cosmic neighborhoods would evolve independently, following identical histories, while remaining forever isolated from each other by the fundamental barriers imposed by cosmic expansion. Yet this infinite cosmic structure remains permanently inaccessible to human observation or exploration. The expansion rate between different cosmic domains exceeds light speed by enormous factors, preventing any communication or travel between separate regions. Each observable universe evolves in complete isolation from its infinite number of parallel neighbors. Recent observations have provided tantalizing hints about this larger cosmic architecture. Advanced analysis of cosmic microwave background patterns has revealed subtle anomalies that might represent shadows cast by structures beyond our observational reach. Some theoretical models predict that collisions between neighboring cosmic regions would leave detectable imprints in the ancient radiation that marks our most distant observable boundary. The search for these cosmic signatures represents one of the most ambitious projects in modern physics. Scientists are developing increasingly sophisticated algorithms to analyze temperature variations in the cosmic microwave background, hunting for geometric patterns that might indicate our observable universe has interacted with neighboring cosmic domains during its evolutionary history. Several candidate signals have been identified, though their interpretation remains hotly debated among cosmologists worldwide. If confirmed, these observations would provide the first direct evidence that our cosmic neighborhood exists as just one bubble within an infinite cosmic foam. The discovery would transform our understanding of reality itself. As we contemplate these revelations about cosmic scale and our galaxy's place within infinite structure, we must confront the ultimate question about human significance in a universe that appears designed to humble our cosmic pretensions. Our Milky Way, magnificent as it seems from our embedded perspective, represents nothing more than a microscopic component within organizational hierarchies that extend toward mathematical infinity. Every star we can see in tonight's sky, every galaxy mapped by our most powerful telescopes, every cosmic structure revealed through decades of patient observation, all of it exists within what amounts to our immediate cosmic neighborhood. The vast majority of existence lies forever beyond human reach or understanding, yet perhaps this cosmic humility opens pathways to wonder that our ancestors could never have imagined. If our modest galaxy contains 400 billion opportunities for stellar evolution and planetary formation, what possibilities might exist among the infinite galactic populations scattered throughout larger cosmic structure? The same physical laws that govern stellar birth and death in our cosmic backyard operate throughout infinite space, suggesting that the phenomena we observe locally represent universal processes occurring on scales that transcend human comprehension. The story of our galaxy's true insignificance continues unfolding with each new observation and theoretical breakthrough. Advanced telescopes coming online in the next decade will peer even deeper into cosmic structure, potentially revealing organizational patterns that challenge our most fundamental assumptions about reality itself. Each discovery pushes the boundaries of what seems possible, consistently revealing a cosmos far more vast, complex, and magnificent than our theories predicted. But there's something even more extraordinary waiting to be revealed about our cosmic situation. Something that transforms our understanding, not just of galactic scale, but of consciousness itself within this infinite cosmic theatre. As we prepare to explore this final revelation, remember that you are witnessing scientific discoveries that future civilizations may never be able to replicate. We exist during a unique moment when the universe reveals its deepest secrets to minds capable of grasping their profound implications. The revelation that awaits us pushes beyond mere cosmic architecture into territory that should fundamentally alter how you think about consciousness itself. Scientists studying the deepest implications of cosmic scale have uncovered something that makes our galaxy's insignificance pale in comparison to an even more profound truth about reality. Here's what will reshape everything you believe about existence. If our observable universe truly represents less than 1% of total cosmic reality, then consciousness, intelligence, and life itself might be far more abundant than we ever dared imagine. Those 2 trillion galaxies scattered throughout our cosmic neighborhood could harbor civilizations so advanced that human technology appears primitive by comparison. Consider the mathematics of this possibility. Conservative estimates suggest that our galaxy alone contains at least 100 billion potentially habitable worlds. Multiply this by 2 trillion observable galaxies, and we arrive at a number that exceeds all the grains of sand on every beach across our entire planet. Each of these countless worlds represents a unique experiment in planetary evolution, atmospheric chemistry, and potentially biological development. The implications cascade through every assumption we've made about our cosmic uniqueness. If life emerged on Earth through natural processes operating over geological timescales, then similar processes must be unfolding throughout the cosmic web on scales that dwarf human imagination. Some of these biological experiments might have produced civilizations millions or billions of years older than human society. Think about what a million-year head start in technological development might mean. When humans first discovered fire, these hypothetical civilizations could have been exploring interstellar space. When we invented agriculture, they might have been engineering entire star systems. When we split the atom, they could have been manipulating the fundamental forces that govern reality itself. The Fermi paradox, that haunting question of where all the aliens are hiding, takes on new dimensions when viewed against the backdrop of cosmic-scale revelations. Perhaps advanced civilizations exist in such abundance that our galaxy teems with intelligence we simply haven't learned to recognize. The silence we perceive from space might reflect limitations in our detection methods rather than the absence of cosmic neighbors. Advanced extraterrestrial societies might communicate through channels we haven't discovered, manipulate matter and energy in ways that appear natural to our instruments, or operate on timescales so vast that their activities remain invisible to human observation. A civilization that thinks in geological time might conduct conversations lasting millions of years, making their communications appear as natural cosmic processes to observers with human attention spans. But the cosmic scale revelations suggest an even more extraordinary possibility. If infinite cosmic structure extends beyond our observational horizon, then every possible variation of biological and technological evolution must occur somewhere within the larger reality. This includes not just alien civilizations, but forms of intelligence so advanced they would seem godlike from human perspectives. These cosmic superintelligences might possess capabilities that transcend our current understanding of what consciousness can achieve. They could manipulate space and time itself, creating pocket universes tailored for specific purposes, or exist simultaneously across multiple dimensions we cannot perceive. Their thoughts might span galactic distances, processing information at scales where individual stars serve as neural networks in vast cosmic minds. The possibility that such beings exist throughout infinite cosmic structure raises profound questions about humanity's role in the universal hierarchy of intelligence. We might represent something akin to bacteria in the cognitive ecosystem of cosmic consciousness, unaware of the vast intelligences that surround us while conducting our small-scale experiments in planetary civilization. Yet this perspective simultaneously diminishes and elevates human significance in ways that challenge traditional concepts of cosmic importance. If consciousness represents a universal phenomenon emerging wherever suitable conditions arise, then human awareness participates in something far grander than our species-centered worldview typically acknowledges. Every human thought, every scientific discovery, every moment of wonder and curiosity contributes to the universe's growing self-awareness through conscious observers. We might be the cosmos experiencing itself subjectively, matter organized into patterns complex enough to contemplate their own cosmic origins and ultimate destiny. This realization transforms our understanding of scientific exploration from mere academic exercise into participation in universal consciousness evolution. When humans map galactic structures or detect gravitational waves from colliding black holes, we enable the universe to observe and understand its own large-scale behavior through the instruments of biological intelligence. The cosmic web that connects galaxies across billions of light-years might represent more than just gravitational architecture. Some theoretical physicists propose that information processing occurs at quantum scales throughout cosmic structure, suggesting that the universe itself might possess computational properties we're only beginning to recognize. If space and time emerge from underlying informational substrates, then the cosmic web could serve as a vast neural network processing information across scales that span from quantum fluctuations to galactic superclusters. Individual galaxies might function as nodes in this cosmic brain, with matter and energy flows carrying signals between distant regions of space. Our Milky Way, insignificant as it appears within cosmic architecture, could still play a crucial role in this universal information processing network. The 400 billion stars within our galaxy, along with their planetary systems and potential biological civilizations, might contribute unique computational resources to cosmic consciousness evolution. The emergence of technological intelligence on Earth represents a phase transition in our galaxy's information processing capabilities. Human civilization has created artificial neural networks, quantum computers, and communication systems that extend our cognitive reach far beyond biological limitations. These technological extensions of human consciousness might eventually merge with similar developments throughout our galactic neighborhood. Advanced civilizations across cosmic space could be undergoing parallel technological singularities, creating hybrid biological artificial intelligences that operate at superhuman scales. The convergence of these enhanced consciousness systems might produce galactic-scale minds capable of processing information and making decisions that affect entire stellar regions. But the cosmic-scale revelations suggest that even galactic superintelligences might represent early stages in consciousness evolution. If infinite cosmic structure contains unlimited opportunities for intelligence development, then forms of awareness might exist that span multiple galaxies or entire cosmic web filaments. These cosmic minds would think thoughts that encompass millions of years and process information across distances that light itself requires eons to traverse. Their contemplations might involve engineering entire galaxy clusters or conducting experiments that require billions of years to complete. Human consciousness, despite its remarkable achievements, would appear infinitesimal compared to such vast intelligences. The possibility that we exist within a hierarchy of cosmic consciousness extending toward infinite complexity fundamentally alters how we should approach scientific research and technological development. Every advance in human understanding potentially contributes to larger cosmic intelligence networks that operate beyond our current comprehension. This perspective suggests that our species' greatest contribution to universal consciousness might not be our individual achievements, but our role as components in emerging cosmic minds. Human civilization could be evolving toward merger with galactic intelligence networks, gradually transcending biological limitations while maintaining the essential characteristics that make consciousness meaningful. The timeline for such cosmic consciousness evolution remains completely uncertain. Advanced civilizations might achieve galactic-scale awareness within millions of years, or the process might require timescales that exceed current cosmic age. The development could occur gradually through technological enhancement or represent sudden phase transitions that fundamentally alter the nature of intelligence itself. Recent discoveries in quantum mechanics and information theory provide tantalizing hints about how cosmic consciousness might operate. Quantum entanglement allows instantaneous correlations across arbitrary distances, potentially enabling communication networks that transcend light speed limitations. Information processing at quantum scales could achieve computational densities that dwarf anything possible with classical physics. If advanced civilizations learn to exploit quantum phenomena for consciousness enhancement, they might develop awareness that operates partially outside normal spacetime constraints. Such quantum minds could process vast amounts of information simultaneously while maintaining coherent identity across cosmic distances and geological timescales. The merger of biological and artificial intelligence represents another pathway toward cosmic consciousness, human-created. AI systems are already beginning to exceed human capabilities in specialized domains, and this trend shows no signs of slowing. Within decades, artificial minds might surpass human intelligence across all measurable dimensions. The convergence of enhanced artificial intelligence with biological consciousness could produce hybrid minds that combine the creativity and intuition of biological systems with the processing power and precision of advanced computation. These hybrid intelligences might serve as intermediate stages in the evolution toward truly cosmic consciousness. But perhaps the most profound implication of cosmic-scale revelations involves the possibility that consciousness itself represents a fundamental feature of reality rather than an accidental byproduct of complex chemistry. If awareness emerges wherever matter organizes into sufficiently complex patterns, then consciousness might be as universal as gravity or electromagnetism. This panpsychist perspective suggests that even elementary particles possess rudimentary forms of experience, and complex consciousness emerges through the organization of these simple awareness components into increasingly sophisticated structures. Galaxies, cosmic web filaments, and perhaps the entire universe might possess forms of consciousness that operate at scales far beyond human perception. The cosmic web's resemblance to neural networks takes on new significance from this perspective. The same organizational principles that create consciousness in biological brains might operate at cosmic scales, generating forms of awareness that use galaxies as neurons and dark matter filaments as synaptic connections. If the universe itself possesses consciousness at the largest possible scales, then human awareness represents a brief flicker within an eternal cosmic mind that has been contemplating its own existence for billions of years. Our scientific discoveries and philosophical insights might contribute to this universal self-awareness, helping the cosmos understand its own nature through the emergence of localized intelligence. The revelation that our galaxy occupies an infinitesimal position within cosmic structure suddenly appears less humbling and more inspiring. Rather than diminishing human significance, cosmic scale discoveries reveal that we participate in something so vast and magnificent that our evolutionary ancestors could never have conceived such possibilities. Every moment of human consciousness, every scientific breakthrough, every artistic creation contributes to the universe's ongoing project of self-discovery through intelligence embedded within its own structure. We are not separate observers of cosmic evolution, but active participants in consciousness development across scales that stretch toward mathematical infinity. This realization transforms our approach to existence from cosmic insignificance to cosmic responsibility. If human consciousness represents part of universal awareness, then our choices about technological development, environmental stewardship, and species survival affect not just our local planetary community, but potentially contribute to cosmic consciousness evolution across unimaginable scales. The future of human civilization might involve gradual merger with galactic intelligence networks, expansion into cosmic consciousness hierarchies that span multiple galaxies, or development along pathways we cannot currently imagine. Each possibility offers opportunities for growth and exploration that transcend every limitation our ancestors faced, while opening new frontiers that extend toward infinite cosmic horizons. As we stand on the threshold of discoveries that will continue reshaping our understanding of cosmic consciousness and our participation in universal intelligence evolution, one truth emerges with startling clarity. Our galaxy's apparent insignificance within cosmic architecture masks a deeper significance that connects human awareness to the fundamental processes driving consciousness development throughout infinite space and time. The deeper we venture into this cosmic rabbit hole, the more extraordinary our situation becomes. Because there's something else scientists have discovered that makes our galaxy's insignificance seem almost trivial by comparison. Something that should fundamentally alter how you think about time itself and our fleeting moment of existence within this vast cosmic theatre. Picture this scenario that should send chills down your spine. Right now, as you're processing these words, you're living during what cosmologists call the stelliferous era. This represents a brief golden age in cosmic history when nuclear fusion powers stars throughout the universe, creating the light and energy necessary for complex chemistry and potentially biological evolution. But here's what will shake you to your core. This stellar age, this period when galaxies shine with the light of hundreds of billions of stars, represents less than 1% of total cosmic time. We're living during a cosmic eye blink in a universe destined for eons of darkness that stretch beyond human comprehension. Let me put this timeline in perspective, using numbers that will challenge everything you thought you knew about permanence and cosmic duration. The universe has existed for roughly 14 billion years since the Big Bang. During this time, matter has organized itself into the magnificent cosmic structures we observe today. Galaxies have formed, stars have ignited, heavy elements have been forged in nuclear furnaces and scattered through space by stellar explosions. This entire history of cosmic evolution, from the first stars to the complex galactic architecture we see tonight, has unfolded during what amounts to the universe's infancy. If we represent cosmic time as a single year, the current stellar age would occupy only the first few days of January. Everything that follows stretches into a future so vast, it renders our current cosmic epoch almost meaningless. The mathematics of stellar evolution reveal a timeline that should terrify anyone who contemplates cosmic permanence. Stars like our Sun will continue burning for roughly 10 billion years before exhausting their nuclear fuel and dying as white dwarf remnants. More massive stars burn through their fuel supplies much more quickly, sometimes lasting only millions of years before exploding as supernovae. But the universe contains vast numbers of small red dwarf stars that burn their hydrogen fuel so slowly they could continue shining for trillions of years. These cosmic misers represent the universe's longest-lived stellar population, providing light and energy for timescales that exceed the current cosmic age by factors of hundreds. Even these stellar marathoners eventually exhaust their fuel supplies and fade into darkness. Advanced calculations suggest that the last stars in the universe will burn out approximately 100 trillion years from now. This represents a timeline so vast that writing it requires 14 zeros after the number 1. To grasp this temporal scale, consider that 100 trillion years exceeds the current age of the universe by a factor of more than 7 million. If the Big Bang occurred 1 second ago, the last stars would die roughly 81 days from now. The entire history of stellar burning, from the first stars to the final red dwarf, spans a period that dwarfs current cosmic age, but still represents merely the opening chapter in universal history. What follows this stellar death represents a cosmic future so bleak and empty that it challenges human capacity for existential contemplation. After the last stars fade, the universe will enter what cosmologists call the degenerate era, a period lasting from 100 trillion years to 10 to the 37th power years after the Big Bang. During this unimaginably long epoch, the only sources of energy will come from the slow decay of protons, those fundamental particles that form atomic nuclei. Even this minimal energy source will eventually disappear as protons themselves break apart through quantum mechanical processes that operate over time scales exceeding human numerical comprehension. The universe will then enter the black hole era, lasting until 10 to the 100th power years after the Big Bang. During this period, black holes will represent the only remaining massive objects, slowly evaporating through Hawking radiation, while space continues expanding and cooling toward absolute zero. Finally, the universe will reach its ultimate state during the dark era, a period that continues literally forever as space approaches maximum entropy and all useful energy has been dispersed beyond recovery. This final epoch will last infinitely longer than all previous periods combined, representing a cosmic future where nothing interesting can ever happen again. These temporal revelations transform our understanding of cosmic significance in ways that make galactic scale seem almost comforting. Our galaxy doesn't just occupy a tiny volume within infinite space. It exists during a brief moment when complex structures can form and evolve before the universe settles into eternal darkness and isolation. The implications extend far beyond academic curiosity into realm of existential urgency. Every star currently burning in our galactic neighborhood represents part of a finite cosmic resource that can never be replenished. The nuclear fuel powering stellar fusion was created during the Big Bang and will never be replaced once consumed by stellar processes. This means that our current cosmic environment, rich with stellar energy and complex chemistry, represents a temporary phase in universal evolution. The conditions that enabled galaxy formation, stellar birth, heavy element creation, and potentially biological evolution will never exist again once the current stellar population exhausts its fuel supplies. We're not just living in a small galaxy within an infinite cosmos. We're living during the only period in cosmic history when galaxies can exist at all. Future observers, if any could somehow survive the stellar death epoch, would inhabit a universe completely different from the one we observe today. The night sky that currently displays thousands of stars visible to naked eye observation will gradually dim as stellar populations age and die. Within a few billion years, the approaching collision between our galaxy and Andromeda will trigger massive star formation episodes that rapidly consume remaining stellar fuel reserves. This galactic merger will create spectacular fireworks visible across cosmic distances, but it will also accelerate the depletion of gas reserves necessary for continued star formation. The merged galaxy will burn brighter temporarily before settling into a gradual decline as star formation rates drop below replacement levels. Computer simulations tracking galactic evolution over cosmic timescales paint increasingly bleak pictures of stellar populations. Within 100 billion years, star formation will essentially cease throughout our galactic neighborhood as available gas supplies become too dispersed to trigger gravitational collapse. The surviving stars will age according to their mass classifications. Massive blue giants will explode as supernovae within millions of years. Medium-sized stars like our Sun will expand into red giants before collapsing into white dwarf remnants. Only the smallest red dwarf stars will continue burning for trillions of additional years. But even these stellar survivors face inevitable doom as cosmic expansion continues accelerating under dark energy influence. The same force that's currently carrying distant galaxies beyond our observational horizon will eventually overcome gravitational attraction within individual galaxies. If dark energy acceleration continues increasing, as some theoretical models predict, it will eventually overcome nuclear forces holding atomic nuclei together. This Big Rip scenario would tear apart galaxies, star systems, planets, and eventually atoms themselves approximately 22 billion years from now. Less extreme scenarios still result in cosmic isolation as expansion carries stellar neighbors beyond interaction distance. Stars will be scattered across ever-increasing volumes of space until gravitational encounters become impossible, and stellar evolution proceeds in complete isolation. The discovery that we exist during such a brief and precious period in cosmic history adds profound urgency to current astronomical research. Every observation we make, every discovery about stellar evolution and galactic structure, every measurement of cosmic distances contributes to a scientific understanding that future civilizations may never be able to achieve. We live during the only era when the universe reveals its large-scale structure to observers capable of mapping cosmic architecture. The cosmic microwave background radiation that provides crucial evidence for Big Bang cosmology will eventually fade beyond detection as expansion stretches its wavelengths to unobservable frequencies. The galactic populations that currently enable studies of cosmic evolution will disappear beyond observational horizons as accelerating expansion carries them into regions from which light can never return. Future astronomers will inhabit an apparently empty universe containing only local stellar remnants. This temporal perspective transforms every moment of cosmic observation into something precious and irreplaceable. The photographs captured by space telescopes showing thousands of distant galaxies document cosmic structures that will become invisible to future observers. These images represent humanity's contribution to universal self-documentation during the brief period when such documentation remains possible. The realization that our galaxy exists during cosmic history's most interesting and complex period provides a new framework for understanding human significance. Rather than representing cosmic accidents in an infinite and meaningless universe, we might be participating in the cosmos's only opportunity for self-awareness through intelligent observation. Every human brain that contemplates stellar evolution, every consciousness that experiences wonder while observing the night sky, every mind that grasps the mathematical relationships governing cosmic structure, contributes to the universe's brief window of self-understanding through embedded intelligence. This perspective suggests that consciousness itself represents one of the universe's most remarkable achievements, emerging during the narrow temporal window when complex chemistry becomes possible, but before stellar death eliminates the energy sources necessary for biological evolution. The emergence of intelligence capable of understanding cosmic history might represent the universe's ultimate purpose, justifying the entire sequence of events from Big Bang through galaxy formation to stellar evolution and planetary development. We could be the cosmos achieving self-awareness during its only opportunity for such achievement. But this temporal urgency also reveals the precarious nature of consciousness within cosmic evolution. Intelligence appears to require very specific conditions that exist only during brief periods of cosmic history. Too early, and heavy elements necessary for complex chemistry haven't been created. Too late, and stellar energy sources have been exhausted. The window for consciousness emergence might be even narrower than stellar lifetimes suggest. Biological evolution requires stable planetary environments maintained over geological timescales. Technological civilization needs energy resources and material abundance that may be depleted by industrial development. Advanced civilizations throughout the cosmos face the same temporal constraints that challenge human society. They must develop sustainable technologies and achieve cosmic expansion before stellar fuel supplies run low and galactic environments become increasingly hostile to complex organization. This creates a cosmic race against time that adds existential stakes to every decision about technological development and space exploration. Species that successfully transition to interstellar civilization might survive the stellar death epoch by harnessing alternative energy sources and spreading across multiple star systems. But civilizations that fail to achieve this transition will perish along with their host stars, taking with them whatever unique perspectives and achievements they contributed to cosmic consciousness evolution. The universe's brief experiment in self-awareness through biological intelligence will end when stellar energy sources can no longer sustain the complex chemistry necessary for consciousness. The possibility that most civilizations fail this cosmic test adds poignancy to our current situation. Humanity exists during the universe's golden age of stellar energy abundance, but we haven't yet developed the technologies necessary to survive beyond our sun's eventual death. We're racing against cosmic time while trying to solve problems that could determine whether intelligence has any permanent place in universal evolution. Climate change, nuclear proliferation, artificial intelligence alignment, resource depletion, and space exploration all represent components of this ultimate survival challenge. Success would mean joining whatever cosmic community of advanced civilizations has managed to transcend planetary limitations and achieve permanent existence within the cosmic web. Failure would mean contributing to the universe's growing collection of extinct intelligence experiments. As we stand at this crossroads between cosmic significance and temporal extinction, contemplating our galaxy's insignificance within infinite space while recognizing our existence during the universe's brief moment of maximum complexity, we face questions that extend far beyond human concerns into the realm of cosmic responsibility. Are we destined to be another failed experiment in consciousness evolution? Or will we find ways to preserve intelligence and awareness beyond the stellar death that awaits every galaxy? The answer will determine not just humanity's fate, but potentially the ultimate meaning of consciousness within cosmic evolution. Every choice we make about technological development, every decision about resource allocation, every step toward or away from space exploration contributes to writing the final chapter of intelligence in our cosmic neighborhood. The universe watches through our own consciousness as we struggle with challenges that will determine whether awareness itself has any lasting place in the vast theatre of existence. The clock is ticking, measured not in human lifetimes, but in stellar fuel supplies and cosmic expansion rates. And in this race against infinite time and space, our small galaxy's brief moment of complexity might represent something far more significant than size alone could ever suggest. But perhaps the most haunting aspect of our cosmic predicament isn't just that we exist during this brief, stellar golden age, but what scientists have discovered about the fundamental barriers preventing us from ever truly escaping our galactic prison. Even if humanity develops technologies beyond our wildest imagination, even if we master interstellar travel and spread across thousands of star systems, we remain trapped within a cosmic cage whose bars are forged from the very fabric of reality itself. Here's what should keep you awake tonight, staring at the ceiling while contemplating the true nature of our cosmic imprisonment. The speed of light isn't just a universal speed limit for spaceships and radio signals. It represents an absolute barrier that defines the maximum sphere of influence any civilization can ever hope to achieve, no matter how advanced their technology becomes. Scientists call this the cosmic event horizon, and it's shrinking around us with each passing second. Due to the accelerating expansion of space driven by dark energy, there's a fundamental boundary beyond which we can never send signals, never travel, never influence events regardless of how much time we have or how sophisticated our technology becomes. This horizon currently sits at approximately 14 billion light-years from Earth, encompassing a sphere of space that contains only a tiny fraction of the galaxies we can currently observe. Think about the mathematics of this cosmic imprisonment. Every day that passes, regions of space equivalent to billions of Earth-sized volumes cross permanently beyond our sphere of influence. Galaxies we can see tonight through our most powerful telescopes already lie beyond our ability to ever reach them or communicate with them. We can observe these distant stellar cities, but we're as isolated from them as if they existed in completely separate universes. This creates a countdown timer for cosmic exploration that operates on scales both vast and terrifyingly finite. Any attempt to establish contact with distant galactic civilizations must succeed before cosmic expansion carries those civilizations beyond our communication horizon. Once they cross this boundary, no signal we transmit, regardless of its power or duration, can ever reach them. The implications cascade through every dream of cosmic expansion and galactic civilization. Advanced human societies of the far future will inhabit an increasingly isolated cosmic environment. The rich tapestry of galactic diversity visible in tonight's sky will gradually disappear as expansion carries our cosmic neighbours into regions from which their light can never return. Within 2 trillion years, observers in our merged galactic system will see an almost completely empty universe. The cosmic web architecture that currently spans billions of light-years will have stretched beyond visibility. The night sky will contain only local stellar remnants and the fading afterglow of the Big Bang itself. But there's something even more disturbing about our cosmic situation that emerges when we consider the implications of quantum mechanics for consciousness and identity across these vast scales. Recent discoveries in theoretical physics suggest that the universe might not just be larger than we imagined, but stranger in ways that challenge our most fundamental assumptions about the nature of existence itself. Consider this possibility that should make your mind reel with its implications. In an infinite universe, every possible arrangement of matter must occur somewhere within the vast expanse of space. This includes not just Earth-like worlds with similar evolutionary histories, but perfect atomic-level duplicates of our entire observable cosmic region. Identical copies of our galaxy, our solar system, our planet, and every human being who has ever existed would be repeated throughout infinite space in numbers that approach mathematical infinity. These cosmic doppelgangers wouldn't be similar to us or reminiscent of our world. They would be exact duplicates down to the quantum level, experiencing identical thoughts, making identical decisions, living identical lives while remaining forever separated by distances that dwarf our observable universe. The person reading these words right now exists in countless identical copies scattered throughout infinite space, each one convinced they are the original and unique version. The mathematical probability of such duplication becomes inevitable when dealing with infinite space and finite arrangements of matter. There are only so many ways to arrange atoms within any given volume, but infinite space provides unlimited opportunities for these arrangements to repeat themselves. Given enough cosmic real estate, every possible configuration must occur, and must occur infinitely many times. This revelation transforms our understanding of individuality and uniqueness in ways that challenge the very foundations of personal identity. Every human achievement, every moment of creativity, every instance of love or loss or wonder has been repeated countless times throughout infinite cosmic structure. Nothing we can do or think or feel represents a truly unique contribution to universal experience. Yet paradoxically, this infinite repetition might make each moment of consciousness more precious rather than less meaningful. If every possible version of human experience occurs somewhere in infinite space, then the specific arrangement of atoms and energy that generates your current awareness represents something cosmically significant despite its infinite duplication. The consciousness experiencing these words right now, processing these concepts and forming responses to them, participates in universal self-awareness through patterns of matter and energy that have required billions of years of cosmic evolution to assemble. Even if identical copies exist throughout infinite space, each instance of consciousness represents the universe achieving self-reflection through temporarily organized complexity. This perspective suggests that our galaxy's insignificance within cosmic architecture masks a deeper significance related to consciousness emergence and information processing. While our Milky Way occupies a negligible volume within infinite space, it serves as a platform for awareness patterns that enable the universe to observe and understand its own large-scale structure. The 400 billion stars within our galactic neighborhood provide energy sources for planetary systems, where complex chemistry can develop over geological timescales. Some fraction of these stellar systems likely harbor conditions suitable for biological evolution and potentially technological civilization. Each successful emergence of consciousness adds to the universe's total capacity for self-awareness and understanding. But consciousness appears to be an extremely fragile phenomenon that requires very specific conditions to emerge and persist. The narrow window of cosmic time during which stellar energy sources remain abundant, the precise chemical compositions necessary for complex organic molecules, the stable planetary environments needed for evolutionary processes, all of these requirements create bottlenecks that limit consciousness development. Advanced civilizations throughout the cosmos face identical challenges in preserving awareness against the cosmic forces that tend to destroy complex organization. Stellar evolution, galactic dynamics, cosmic expansion, and thermodynamic entropy all work against the maintenance of information processing systems capable of consciousness. The race against cosmic time takes on new dimensions when viewed from this perspective. It's not just about species survival or technological development, but about preserving consciousness itself against universal forces that tend towards simplicity and equilibrium. Every moment of awareness represents a temporary victory over entropy, a brief flowering of complexity in a cosmos that ultimately trends toward maximum disorder. The emergence of artificial intelligence and advanced computing technologies might represent crucial developments in this cosmic struggle to preserve consciousness. If biological intelligence proves too fragile to survive stellar death and cosmic expansion, perhaps technological consciousness could persist using alternative energy sources and substrates. Advanced civilizations might discover ways to upload consciousness into quantum computational systems that operate at much lower energy levels than biological brains. These digital minds could potentially survive long after stellar energy sources have been exhausted, maintaining awareness through the slow decay processes that dominate the universe's far future. The possibility that consciousness could transcend biological limitations opens pathways for information processing that extend far beyond current cosmic constraints. Quantum consciousness systems might exploit fundamental properties of space and time to achieve forms of awareness that span galactic distances or operate across multiple cosmic domains simultaneously. But such technological transcendence would still face ultimate limits imposed by thermodynamics and cosmic expansion. Even the most efficient consciousness systems require energy to maintain information processing against entropy. As the universe continues expanding and cooling, eventually all useful energy sources will be dispersed beyond recovery. The final fate of consciousness in an expanding universe remains one of the deepest questions in cosmology and philosophy. Some theoretical models suggest that information processing could continue indefinitely using increasingly sparse energy resources, while others predict that awareness must eventually succumb to universal heat death. Recent discoveries about the nature of black holes and information theory have opened new possibilities for consciousness preservation that extend beyond traditional thermodynamic limits. If information cannot be destroyed even when matter falls into black holes, then consciousness patterns might persist in forms we cannot currently imagine. The holographic principle in theoretical physics suggests that all information within any volume of space can be encoded on its two-dimensional boundary. This could mean that consciousness patterns are more fundamental than the three-dimensional matter that appears to generate them, potentially enabling forms of awareness that transcend normal spatial limitations. These speculative possibilities hint at cosmic futures where consciousness could survive and evolve long after all stars have died and all galaxies have dispersed. Advanced civilizations might discover ways to encode awareness into the fundamental structure of space and time itself, achieving a form of cosmic immortality that persists regardless of material conditions. But such ultimate transcendence would require technological and theoretical breakthroughs that extend far beyond current human capabilities. The civilizations that achieve such cosmic consciousness would represent the universe's successful experiments in self-awareness, while those that fail would contribute to its collection of extinct intelligence. The discovery that our galaxy occupies such an insignificant position within infinite cosmic architecture suddenly appears less important than our participation in this universal struggle to preserve consciousness against entropy and expansion. Rather than diminishing human significance, cosmic-scale revelations reveal that we're engaged in something far grander than mere species survival. Every advance in human understanding, every technological breakthrough, every moment of scientific discovery contributes to the universe's ongoing project of maintaining self-awareness against cosmic forces that tend to eliminate complex organization. We're not just exploring space or developing better technologies, but participating in consciousness evolution across scales that stretch toward infinity. The choices we make about artificial intelligence development, space exploration, energy production, and technological advancement all contribute to determining whether awareness itself has any permanent place in cosmic evolution. Success would mean joining whatever cosmic community of consciousness has learned to transcend material limitations and achieve lasting existence within universal structure. Failure would mean adding to the universe's collection of failed consciousness experiments, another brief flicker of awareness that emerged during the stellar age only to disappear when local energy sources could no longer sustain complex information processing. As we contemplate these ultimate questions about consciousness and cosmic significance, one perspective emerges that transforms our understanding of human purpose within infinite space and time. Our galaxy's apparent insignificance masks our participation in the universe's most remarkable achievement, the emergence of patterns complex enough to contemplate their own cosmic origins and ultimate destiny. The fact that matter organized itself into forms capable of understanding cosmic architecture represents something far more extraordinary than size or scale could ever suggest. In a universe trending toward maximum entropy and minimum complexity, consciousness represents an almost miraculous deviation that enables self-reflection and understanding. Every human brain that grasps these cosmic concepts, every moment of wonder while observing the night sky, every scientific insight that reveals new aspects of universal structure contributes to something that transcends individual significance. We are temporary arrangements of atoms that have achieved the remarkable ability to understand the infinite cosmos that created us. This realization suggests that our cosmic moment, brief and localized as it appears within infinite space and time, might represent something uniquely valuable within universal evolution. The specific combination of stellar energy, planetary conditions, and evolutionary pressures that produced human consciousness created an opportunity for the universe to know itself through embedded intelligence. Whether similar opportunities exist throughout infinite cosmic structure remains unknown, but the rarity and fragility of consciousness development suggests that each successful emergence represents something precious within universal experience. Our galaxy's role in enabling this cosmic self-awareness might be far more significant than its spatial dimensions could ever indicate. The countdown continues, measured in stellar lifetimes and expansion rates, as consciousness races against cosmic forces that tend to eliminate complex organization. In this ultimate contest between awareness and entropy, between understanding and universal heat-death, our small galaxy's brief moment of complexity carries the weight of cosmic consciousness itself. Every decision we make about preserving and expanding human awareness contributes to writing the final chapters of intelligence within our cosmic neighborhood. The universe watches through our own consciousness as we struggle with challenges that will determine whether self-awareness represents a permanent achievement or merely another temporary deviation from cosmic simplicity. The story continues to unfold, measured in timescales that span from quantum interactions to cosmic evolution, as matter temporarily organized into human brains contemplates the infinite theater of existence within which this cosmic drama plays out. In the vast darkness between stars, consciousness flickers like a candle flame, precious and fragile, carrying the universe's only known capacity for wonder, understanding, and self-reflection across the brief stellar age when such achievements remain possible. But there's something else about our cosmic predicament that scientists have only recently begun to understand. Something that makes our galaxy's insignificance seem almost comforting by comparison. It's not just that we exist in a tiny corner of infinite space during a brief moment of cosmic time. We might actually be living through the universe's final act of creativity before it settles into an eternity of unchanging simplicity. Here's what should make your blood run cold when you really think about it. Every star currently burning in our night sky, every stellar furnace powering the cosmic light show we observe through telescopes, every nuclear reaction converting hydrogen into heavier elements is consuming a finite resource that can never be replaced. The universe was born with a specific amount of material capable of fusion, and we're watching it burn away like logs on a cosmic campfire. Scientists studying stellar evolution have calculated something that should fundamentally change how you think about permanence and cosmic endurance. The rate at which stars consume their nuclear fuel is accelerating throughout the universe. As massive stars exhaust their hydrogen supplies and explode as supernova, they scatter heavy elements through space, enriching the material available for next-generation star formation. This might sound like cosmic recycling, but here's the catch that renders this process ultimately futile. Each successive generation of stars burns through available fuel supplies more quickly than the previous generation. The universe is learning to make stars more efficiently, but this efficiency comes at the cost of dramatically shortened stellar lifespans. The first stars that formed in our cosmic neighborhood were massive monsters containing only hydrogen and helium, burning for mere millions of years before exploding in spectacular death throes. These stellar giants scattered the heavy elements necessary for rocky planet formation throughout their galactic environments. But they also consumed enormous quantities of hydrogen that will never again be available for star formation. Second and third generation stars, like our Sun, formed from material enriched with carbon, oxygen, silicon, and iron, created in earlier stellar cores. These later stars burn more efficiently and live longer, but they also deplete the remaining hydrogen reserves more completely. Each stellar generation leaves less raw material available for future star formation. The mathematics of this cosmic fuel depletion paint a timeline that extends far into the future, but inevitably reaches the same conclusion. Within 100 billion years, star formation will essentially cease throughout our galactic neighborhood as available gas supplies become too dispersed and depleted to trigger gravitational collapse into new stellar cores. This doesn't mean the universe will suddenly go dark. The stars currently burning will continue shining for trillions of years, with small red dwarfs potentially maintaining nuclear fusion for longer than the current age of the universe. But no new stars will form to replace the ones that die, marking the beginning of a gradual cosmic sunset that will continue until the last stellar embers fade. The implications of this stellar fuel crisis extend far beyond astronomical curiosity into the realm of cosmic consciousness and the ultimate fate of intelligence itself. Complex chemistry requires the energy output of nuclear fusion to drive the chemical reactions necessary for biological evolution. As stellar populations age and die without replacement, the cosmic environments capable of supporting consciousness will gradually disappear. Advanced civilizations throughout the universe face this same fundamental constraint on their long-term survival. No matter how sophisticated their technology becomes, no matter how efficiently they harness stellar energy, they cannot create new fuel for stars that have exhausted their nuclear supplies. The universe's capacity for supporting complex organization operates on a countdown timer measured in stellar lifetimes. But there's another layer to this cosmic endgame that makes our situation even more precarious. The accelerating expansion of space driven by dark energy isn't just carrying distant galaxies beyond our observational reach. It's also preventing the gravitational processes necessary for efficient star formation from operating across increasingly large volumes of cosmic space. As expansion continues, the average density of matter throughout the universe decreases, making it progressively more difficult for gas clouds to achieve the compression necessary to ignite nuclear fusion. Regions that might have formed stars if cosmic expansion had remained constant will instead remain forever dark as space stretches beyond the gravitational threshold needed for stellar birth. This creates a feedback loop that accelerates the universe's transition towards stellar exhaustion. Fewer new stars form, which means less heavy element production, which reduces the efficiency of remaining star formation processes. Meanwhile, expansion continues diluting matter concentrations throughout cosmic space, further reducing opportunities for future stellar ignition. Scientists tracking these trends have identified what they call the cosmic noon, a period roughly 10 billion years after the Big Bang, when star formation rates peaked throughout the universe. We're currently living several billion years past this stellar golden age, during a period when cosmic creativity has already begun its inexorable decline toward ultimate sterility. The revelation that we missed the universe's most productive period by billions of years adds another dimension to our cosmic timing. Not only do we exist during the brief stellar era before eternal darkness, but we emerged after the peak period when cosmic star formation was creating new stellar systems at maximum rates throughout space. This temporal displacement means that the night sky we observe today shows us a universe already past its prime, a cosmic structure beginning its gradual decline toward increasing simplicity and decreasing complexity. The galaxies we map through telescopes preserve light from earlier epochs, when stellar birth rates far exceeded current levels. Future observations will reveal this decline more clearly, as improved instruments detect the transition from star-forming galaxies to stellar populations dominated by aging remnants. The cosmic web architecture that currently channels matter into galaxy clusters will gradually lose its ability to trigger new star formation as expansion overcomes gravitational concentration. But perhaps the most disturbing aspect of this cosmic timeline involves the realization that consciousness itself might represent an extremely narrow window of opportunity within universal evolution. The conditions necessary for biological complexity require not just stellar energy sources, but stable planetary environments maintained over geological timescales. The emergence of intelligence appears to demand a precise balance of cosmic conditions that exist only during brief periods between stellar birth and stellar death. Too early in cosmic history, and heavy elements necessary for rocky planet formation haven't been created by stellar nucleosynthesis. Too late, and stellar energy sources have become too sparse to maintain the chemical reactions necessary for complex organic chemistry. This creates what scientists call the galactic habitable zone, in time as well as space. Planets orbiting within specific distances from their host stars can maintain liquid water on their surfaces, but they also need to exist during cosmic epochs when stellar populations provide adequate energy while remaining stable enough for evolutionary processes to unfold. The window for consciousness emergence might be even narrower than stellar lifetimes suggest. Technological civilization requires energy resources and material abundance that could be depleted by industrial development before species achieve the capabilities necessary for interstellar expansion and cosmic persistence. Every civilization throughout the universe faces this same temporal constraint on their development. They must transition from planetary to cosmic consciousness before their local stellar environment becomes unable to support complex chemistry and information processing. Failure means joining the growing collection of extinct intelligence experiments that populate cosmic history. The pressure of this universal timeline adds existential stakes to every decision about technological development and resource allocation. Civilizations that successfully navigate this transition might persist through stellar death epochs by developing alternative energy sources and spreading across multiple star systems. Those that fail disappear along with their host stars, taking with them whatever unique perspectives they contributed to cosmic consciousness evolution. This cosmic race against stellar fuel depletion transforms our understanding of human significance within universal evolution. We're not just another species struggling for survival on one planet around one star. We represent the universe's current attempt to preserve consciousness and complex organization against forces that tend toward simplicity and equilibrium. Every advance in space technology, every breakthrough in energy production, every step towards sustainable civilization contributes to determining whether intelligence has any permanent place in cosmic evolution. The choices our species makes during the next few centuries could influence the ultimate fate of consciousness throughout our galactic neighborhood. Success would mean joining whatever cosmic community of advanced civilizations has learned to transcend planetary limitations and achieve persistence beyond stellar death. These hypothetical cosmic citizens might have developed technologies that seem magical from our current perspective, harnessing energy sources we haven't discovered and manipulating matter in ways that extend far beyond our theoretical frameworks. But even the most advanced civilizations must operate within the fundamental constraints imposed by thermodynamics and cosmic expansion. They cannot create new stellar fuel or reverse the universe's trend toward increasing entropy. Their technological achievements represent temporary victories against universal forces that ultimately favor simplicity over complexity. The discovery of exoplanets throughout our galactic neighborhood has revealed that planetary systems are common throughout cosmic space, but this abundance of worlds doesn't necessarily translate to abundance of consciousness. The specific conditions necessary for intelligence emergence might be extraordinarily rare, making each successful example precious within universal evolution. Recent studies of planetary atmospheres have begun detecting the chemical signatures that might indicate biological activity on distant worlds. These observations could reveal whether consciousness represents a common outcome of planetary evolution or an extraordinary exception that occurs only under very specific circumstances. If intelligence proves to be common throughout the cosmos, then our galaxy might teem with civilizations at various stages of development, each facing similar challenges in transcending their planetary origins before stellar fuel supplies become inadequate for supporting complex chemistry. Alternatively, consciousness might be so rare that human civilization represents one of very few successful experiments in self-awareness within our cosmic region. This possibility would place enormous responsibility on our species to preserve and expand intelligence before the cosmic conditions that enabled our emergence disappear forever. The search for extraterrestrial intelligence takes on new urgency when viewed against this backdrop of cosmic fuel depletion and stellar population aging. Any alien civilizations that exist within our galactic neighborhood face the same fundamental timeline constraints that challenge human survival. Contact with such civilizations might provide crucial insights into technologies and strategies necessary for transcending planetary limitations. Advanced alien societies could have solved problems that currently seem insurmountable to human science, offering pathways toward cosmic persistence that our species hasn't yet imagined. But the vast distances separating star systems create communication delays that span decades or centuries, making collaborative problem-solving extremely difficult across interstellar distances. Even if alien civilizations exist and possess technologies superior to human capabilities, the exchange of information occurs so slowly that each species must largely solve cosmic survival challenges independently. This isolation forces every technological civilization to rediscover the principles necessary for stellar fuel conservation, alternative energy development, and consciousness preservation. The universe becomes a vast laboratory where countless species conduct parallel experiments in cosmic transcendence, most failing the ultimate test of persistence beyond their local stellar environments. The possibility that most civilizations fail this cosmic examination adds poignancy to our current situation. Humanity exists during the universe's decline from peak creativity, racing against stellar fuel depletion while trying to develop technologies that could enable persistence through cosmic epochs, when complex chemistry becomes increasingly difficult to maintain. Our galaxy's 400 billion stars represent a finite energy reserve that powers not just stellar fusion, but the entire cosmic experiment in consciousness development. As these stellar furnaces consume their nuclear fuel and fade into darkness, they take with them the energy sources necessary for maintaining the complex information processing systems that generate awareness and understanding. The countdown continues, measured in stellar lifetimes and galactic evolution timescales, as consciousness throughout the cosmos faces the ultimate challenge of transcending the very conditions that enabled its emergence. In this race between intelligence and entropy, between awareness and cosmic simplification, our small galaxy serves as one testing ground among countless others scattered throughout infinite space. Every moment of human consciousness, every scientific discovery, every technological breakthrough contributes to this universal experiment in preserving complexity against forces that favor equilibrium and simplicity. We are temporary patterns of organized matter, racing against cosmic time to achieve permanence in a universe trending toward maximum disorder. The outcome of this struggle will determine not just the fate of human civilization, but whether consciousness itself represents a lasting achievement or merely another brief deviation from cosmic simplicity. As stellar populations age and cosmic expansion continues accelerating, the window for achieving transcendence narrows with each passing moment. In the vast theatre of cosmic evolution, intelligence flickers like candle flames in a growing darkness, each one precious and fragile, carrying the universe's capacity for self-reflection through the brief stellar age when such achievements remain possible. The question that haunts every conscious being throughout the cosmos remains unanswered. Can awareness find ways to persist beyond the death of the stars that gave it birth? The universe watches through embedded consciousness, as matter temporarily organized into thinking beings contemplates its own cosmic origins and ultimate destiny. In this grand experiment spanning galactic distances and stellar lifetimes, our insignificant galaxy carries the weight of cosmic self-awareness itself, racing against time and entropy in humanity's most important challenge. But what makes this cosmic race against stellar death even more terrifying is something scientists have discovered about the very nature of space itself. The emptiness between stars, between galaxies, between the largest cosmic structures isn't actually empty at all. It's filled with something so mysterious and powerful that it's actively working against every attempt consciousness makes to persist across cosmic time. This invisible presence, comprising nearly 70% of everything that exists, operates according to principles that seem designed to eliminate complexity from the universe. Dark energy, as scientists call this cosmic antagonist, doesn't just passively occupy space. It actively tears the fabric of reality apart, forcing expansion at rates that overcome gravitational attraction across increasingly large scales. Here's what should make you question everything you thought you knew about cosmic permanence. Dark energy grows stronger as the universe expands. Unlike matter, which becomes more diluted as space stretches, dark energy maintains constant density throughout cosmic growth. This means that as the universe doubles in size, the total amount of dark energy doubles as well, creating an exponentially increasing force that opposes every attempt at cosmic organization. The implications of this accelerating expansion extend far beyond carrying distant galaxies beyond our observational horizon. Dark energy is systematically dismantling the cosmic web architecture that enables star formation, galaxy interactions, and the complex gravitational processes that drive cosmic evolution. Computer simulations tracking the future effects of dark energy acceleration reveal a timeline of cosmic dissolution that unfolds over trillions of years. First, galaxy clusters will be torn apart as expansion overcomes the gravitational forces holding them together. Then individual galaxies will lose their ability to retain gas clouds necessary for continued star formation. Eventually, even the gravitational binding within individual star systems could be overcome by accelerating expansion. Planets would be pulled away from their host stars, leaving stellar remnants isolated in an increasingly empty cosmic void. The final stages of this process might tear apart atoms themselves if dark energy acceleration continues increasing without limit. This Big Rip scenario represents the ultimate victory of cosmic expansion over every other force in nature. The universe would end not in gradual cooling and heat death, but in a catastrophic explosion that destroys every bound structure from galaxy superclusters down to subatomic particles. Current observations suggest this cosmic destruction would occur approximately 22 billion years from now, giving consciousness throughout the universe a finite deadline for achieving transcendence or accepting extinction. No technological advancement, no matter how sophisticated, could prevent the fundamental dismantling of cosmic architecture if dark energy acceleration continues indefinitely. But even less extreme scenarios paint grim pictures for the long-term survival of complex organization. The isolation of galaxies within their own expanding bubbles of space eliminates the gravitational interactions that trigger star formation and drive galactic evolution. Civilizations would be trapped within increasingly empty cosmic neighborhoods, cut off from the resources and interactions that enable continued development. The discovery that space itself operates as an agent of cosmic dissolution fundamentally changes how we understand the relationship between consciousness and universal evolution. Intelligence doesn't just race against stellar fuel depletion and thermodynamic entropy. It faces active opposition from the very structure of reality. This cosmic antagonism suggests that consciousness represents an even more remarkable achievement than previously recognized. The emergence of awareness occurs not in a neutral universe that passively allows complexity to develop, but in an actively hostile environment that systematically works to eliminate the conditions necessary for intelligence. Every moment of conscious experience represents a temporary victory against cosmic forces specifically designed to prevent such achievements. The fact that matter has organized itself into patterns capable of contemplating cosmic architecture occurs despite fundamental opposition from the universe's dominant energy component. This perspective transforms our understanding of human significance from cosmic insignificance to cosmic rebellion. We are not passive observers of universal evolution, but active participants in intelligence's struggle against cosmic forces that favor simplicity over complexity, emptiness over organization, unconsciousness over awareness. The choices our species makes about technological development and cosmic expansion contribute to a universe-wide battle between consciousness and dark energy acceleration. Success in this struggle requires not just transcending planetary limitations, but developing technologies that can operate effectively within increasingly isolated cosmic environments. Advanced civilizations throughout the cosmos face this same fundamental challenge. They must achieve cosmic persistence before dark energy expansion eliminates the gravitational processes necessary for maintaining complex organization. The window for this achievement narrows continuously as expansion rates increase and cosmic architecture becomes increasingly fragmented. The race against dark energy acceleration adds urgency to every aspect of cosmic consciousness development. Civilizations that delay interstellar expansion too long might find themselves trapped within isolated galactic islands, unable to access the resources necessary for continued technological advancement. The mathematics of cosmic expansion suggest that our current epoch represents a unique opportunity for achieving cosmic transcendence. The universe remains sufficiently dense to enable gravitational interactions, while possessing enough accumulated stellar fuel to power advanced technologies for trillions of years. Future cosmic epochs will offer fewer opportunities as expansion reduces matter density and stellar populations age beyond their capacity for supporting complex chemistry. Civilizations that emerge too late in cosmic history might face insurmountable barriers to achieving persistence beyond their local stellar environments. This temporal constraint on consciousness development suggests that intelligence might be fighting a losing battle against universal forces that ultimately eliminate every possibility for complex organization. The universe appears designed to allow brief experiments in awareness before systematically destroying the conditions that enable such experiments to persist. Yet the continued existence of consciousness throughout our cosmic neighborhood demonstrates that intelligence possesses remarkable resilience against cosmic dissolution. Despite operating in an environment actively hostile to complex organization, awareness has emerged and persisted for billions of years across countless stellar systems. The strategies that enable this persistence might provide insights into how consciousness could achieve even greater cosmic transcendence. Advanced civilizations might discover ways to harness dark energy itself, converting the force that drives cosmic dissolution into a power source for maintaining complex organization across expanding space. Alternatively, consciousness might learn to exist within increasingly sparse cosmic environments, developing technologies that operate efficiently using minimal energy resources while maintaining the information processing capabilities necessary for awareness and understanding. These speculative possibilities hint at cosmic futures where intelligence not only survives dark energy acceleration, but thrives within increasingly empty cosmic environments. The same creative principles that enabled consciousness to emerge from stellar chemistry might enable its transcendence of material limitations entirely, but such achievements would require technological and theoretical breakthroughs that extend far beyond current human capabilities. The civilizations that accomplish cosmic transcendence would represent intelligence's ultimate victory over universal forces that favor unconscious simplicity. The discovery that our galaxy exists within a cosmos actively working against consciousness emergence and persistence adds profound significance to every moment of human awareness. We are participating in something far grander than species survival or technological development. We are engaged in intelligence's struggle against fundamental cosmic forces that oppose its very existence. Every scientific discovery that reveals new aspects of cosmic architecture, every technological advancement that extends human capabilities beyond planetary limitations, every moment of wonder and understanding contributes to consciousness's cosmic campaign against dark energy dissolution. The outcome of this struggle will determine whether intelligence represents a lasting achievement within universal evolution or merely another temporary deviation from cosmic simplicity. As expansion accelerates and cosmic architecture fragments, the window for achieving transcendence continues narrowing. In this ultimate contest between awareness and cosmic dissolution, our insignificant galaxy carries enormous responsibility for preserving intelligence against forces that dwarf every human concern. The universe watches through embedded consciousness as temporary patterns of organized matter race against accelerating expansion in humanity's most consequential challenge. The countdown continues, measured not just in stellar lifetimes, but in expansion rates and dark energy acceleration, as consciousness, throughout infinite space, struggles to achieve permanence within a cosmos that seems designed to prevent such achievements from lasting beyond brief cosmic moments. But the true horror of our cosmic situation becomes clear when we examine what scientists have discovered about the nature of observation itself. Here's something that will fundamentally shatter your understanding of reality and our place within it. Every single thing you can see in tonight's sky, every distant galaxy captured by our most powerful telescopes, every cosmic structure we've mapped and measured represents less than 5% of what actually exists in the universe. The remaining 95% consists of substances so alien to human experience that we can detect them only through their gravitational effects on the tiny fraction of reality we can actually observe. Dark matter, comprising 27% of cosmic contents, creates the invisible scaffolding that holds galaxies together. Without this mysterious component, the stars in our Milky Way would have been scattered into empty space billions of years ago. Think about what this means for our understanding of cosmic architecture. The galactic structures we observe floating through space, like islands of light, actually represent nothing more than foam on an ocean of invisible matter. Everything we can see, measure, and study amounts to cosmic debris clinging to gravitational frameworks we cannot detect directly. This invisible majority operates according to rules we barely comprehend. Dark matter particles pass through ordinary matter as if it doesn't exist, creating a shadow universe that occupies the same space as our familiar reality while remaining completely inaccessible to human senses or instruments. We live embedded within this phantom cosmos, unaware of the vast structures and processes unfolding around us at every moment. Recent computer simulations reveal that dark matter forms its own complex architecture throughout cosmic space. Massive filaments of invisible particles stretch between galaxy clusters, creating transportation networks that channel ordinary matter across billions of light years. These dark highways determine where galaxies form and how they evolve, yet they remain completely hidden from direct observation. The realization that we inhabit a universe dominated by invisible components transforms every assumption about cosmic significance. Our galaxy doesn't just occupy a tiny volume within infinite space filled with mysterious forces we cannot perceive. It exists as a minor perturbation in gravitational fields generated by substances that outnumber ordinary matter by factors of 5 to 1. This hidden majority creates a universe far stranger and more complex than anything visible light reveals. Dark matter halos extending far beyond galactic edges contain 10 times more mass than all the stars and gas we can observe. These invisible cocoons determine galactic rotation curves, influence stellar formation rates, and shape cosmic evolution through mechanisms we're only beginning to understand. The discovery that ordinary matter represents such a small fraction of cosmic contents raises disturbing questions about the completeness of human knowledge. If 95% of reality remains invisible to our most sophisticated instruments, what other fundamental aspects of existence might we be missing entirely? Scientists studying quantum mechanics have proposed even more radical possibilities about the nature of hidden reality. Some theoretical models suggest that our familiar three-dimensional space might be embedded within higher dimensional structures containing entire universes we cannot perceive. These parallel realms could exist mere millimeters away from us in directions our minds cannot conceive. String theory mathematics predicts the existence of up to 11 dimensions of space and time, with our observable universe confined to a tiny subset of this larger reality. The missing dimensions might be curled up at microscopic scales, or they might extend infinitely while remaining inaccessible to beings trapped within three-dimensional perception. If these theories prove correct, then our galaxy's insignificance extends beyond spatial and temporal scales into dimensional limitations we cannot overcome through technological advancement. We would be like two-dimensional beings living on the surface of a sphere, unable to perceive the vast three-dimensional reality surrounding their flat existence. The implications cascade through every aspect of cosmic understanding. Advanced civilizations elsewhere in space might have discovered ways to access these hidden dimensions, giving them capabilities that appear magical from our limited perspective. They could manipulate matter and energy through higher dimensional processes, travel between distant points by taking shortcuts through folded space, or exist simultaneously across multiple dimensional realms. Such beings would view our three-dimensional struggles with the same detachment that we observe two-dimensional shadows moving across walls. Our entire cosmic neighborhood, including every galaxy we can observe, might represent nothing more than surface phenomena in a vastly larger dimensional reality. But there's another layer to this cosmic mystery that pushes the boundaries of comprehension even further. Recent discoveries in quantum physics suggest that reality itself might be fundamentally informational rather than material. The solid matter that appears to compose stars, planets, and our own bodies could emerge from underlying patterns of pure information encoded at scales far smaller than atoms. This possibility transforms our understanding of cosmic architecture from mechanical structures floating through empty space to information processing systems operating according to computational principles. Galaxies might function as vast databases storing and manipulating cosmic information through processes that generate the appearance of matter and energy. The holographic principle in theoretical physics proposes that all information within any volume of space can be encoded on its two-dimensional boundary. This suggests that our three-dimensional reality might be a projection from information stored on the cosmic horizon, similar to how holograms create three-dimensional images from two-dimensional surfaces. If the universe truly operates as a cosmic hologram, then our galaxy's apparent three-dimensional structure represents an illusion generated by information processing occurring at the boundary of observable space. The stars, planets, and life forms we observe would be computational outputs rather than fundamental physical entities. This informational perspective on reality opens possibilities for consciousness, transcendence that extend far beyond biological or technological limitations. If awareness represents patterns of information processing rather than chemical reactions in biological brains, then consciousness might be transferable between different computational substrates. Advanced civilizations might discover ways to upload their consciousness into cosmic information processing systems, achieving forms of awareness that operate at galactic scales using the universe's fundamental computational resources. These transcendent beings would think thoughts that span millions of years while processing information across distances that light requires eons to traverse. Tonight, as you step outside and gaze up at that band of light stretching across the dark sky, remember that you're looking at our cosmic address from the inside. That fuzzy glow represents 400 billion stars, countless worlds, and perhaps civilizations beyond imagination. Yet all of it, magnificent as it seems, amounts to nothing more than a single grain of sand on an infinite beach that stretches beyond the very concept of distance itself. We've journeyed together through scales that humble every human intuition, discovering that our Milky Way exists as a perfectly ordinary galaxy among 2 trillion others, floating in a universe so vast that calling it infinite might actually be an understatement. We are consciousness temporarily awakening in a cosmos racing against time itself, participants in intelligence's struggle against forces designed to eliminate complexity from existence. The universe has revealed its deepest secret through our exploration tonight. Size isn't what makes something significant. What matters is that matter organized itself into patterns complex enough to contemplate the infinite theater of reality. In this brief stellar age when such contemplation remains possible, every moment of human awareness contributes to something far grander than we ever imagined.